Hi, I'm Charles Scott Emopo from the Global Eco-Development Team of Huawei's Consumer Business, and I oversee global partnerships for Mobile Office. Me and my colleague Francesco Florio will be sharing some insights into a couple of Huawei's software capability engines, the Share OneHop Kit. I'll also be sharing very briefly a one-touch photo printing example from one of our photo printing partners, CEWE, whose customers now benefit from this capable solution for instant pairing, multi-file transfer, and printing from smart devices. Highlighting three traditional cross-device file transfer methods with their cons, some may want to highlight cable connectivity, which is fully dependent on a USB cable, a card reader, or the likes of, as a bridge between devices. The downside to this, amongst other issues, is loss of connection leading to repeated transmission failures. There's also the option of Bluetooth Wi-Fi connectivity for file transfer, except this could suffer slow transmission over local area network, as well as slow file transfers via Bluetooth. We can also consider other internet-based tools with the dependency on internet access, which in itself creates more vulnerability to privacy risks, and the entire file transfer is at the mercy of the network's stability. We've also found that over 90% of consumers express grave privacy concerns and overall data security. So, to help bridge this connectivity gap more effectively, Huawei introduced its NFC high-speed file transfer solution called Sharekit, allowing high-speed wireless connection between any Huawei phone with EM user interface 9.0 and above, and most Windows, Android, and Linux OS devices that support Bluetooth and Wi-Fi connectivity. Here's the simple technology roadmap in which Huawei's Sharekit is based upon. So there's Bluetooth to identify devices nearby, authentication of connection with nearby devices, then peer-to-peer Wi-Fi channels are established to ensure file transfer between devices at incredibly high speeds. CEWE are one of our partners in the photo printing industry who hold a significant retail presence of about 20,000 outlets for consumer use across Europe. CEWE, in conjunction with Huawei Share, has improved the human-computer interaction for better user experience, such that users are now able to wirelessly pair their smart devices with any compliant CEWE photo printer vending machine, whilst within proximity of the machine, and are able to share multiple photo files via this secure channel for instant printing. And we encourage more diverse global partnership scenarios that improve consumer experience with Share and OneHop, and others from Huawei's list of clever capability kits. Huawei's OneHop Kit, which some may regard as a counterpart of Sharekit, was developed as a full solution for seamless multi-device communication via NFC technology, where smartphone and other devices can be connected with a single tap. OneHop's NFC connectivity is popular for its simplicity and ease of use, as opposed to QR code scanning to establish a P2P connection. It is also a more secure and seamless protocol over the option of Bluetooth or Wi-Fi for smartphone connectivity to various other devices. The file sharing process with OneHop consists of two simple steps. The user selects file from their phone to transfer, and then taps the phone on the NFC tag on the recipient device to initiate high-speed file transfer. This is both beneficial to end users on improved user experience and to the developers as an innovative and unique selling point for their own consumer product or service. Huawei's OneHop Kit has been popular across various third-party devices since its inception. So, devices like tablets, PCs, smart TVs, speakers, IoT devices, high car, and most wearables, with several applicable scenarios like multi-screen collaboration, pairing, data sharing, file transfer, projection, music playback, and connecting to a network. Again, we look forward to a more robust ecosystem through our partnerships globally, where more tech consumers are able to benefit from these device capability enhancements. I'll now refer to my colleague Francesco Florio to touch on Sharekit integration along with more technical insights.
Let's go into the technical part, starting with the flow needed to integrate Sharekit. First of all, it is required to sign a cooperation agreement. This stage is important to define the scenarios in which Sharekit will be used to improve the device capabilities and the user experience. Only once the cooperation is done, the access to Sharekit SDK is provided. Next step is to check hardware specification to be sure Sharekit will be fully compatible. If everything is okay, the integration can start. Sharekit SDK is provided with UX design specification, development guide, and sample codes. It's better to follow all these documents carefully. In this way, the integration will be fast and smooth. Later, I will describe the main steps to follow to integrate Sharekit in an Android app. Once the integration is done, there is a well-known certification workflow, and when all the test cases will have been successfully passed, the product will be ready for the consumer market. Sharekit is automatically included in MUI 9.0 or later. For other Android devices, the system requirement is Android 8.0 or later and API level 26 or higher. The device has to support direct Wi-Fi and Bluetooth 4.0 with low energy. Sharekit could be also used into Linux devices with kernel version 3.10 or later and with an environment that supports dynamic library loading and OpenSSL. Furthermore, Sharekit depends on WPA supplicant 2.9 and Bluetooth 5.52. All most common Wi-Fi protocols are supported. Direct Wi-Fi and Bluetooth 4.0 with low energy and GATT support are also required. Sharekit can also be integrated into Windows PC apps. For Bluetooth and Wi-Fi, the same requirements we already discussed are also valid here. In the documentation, there is a list of compatible Intel chips. Windows support is not ready yet, but it will be coming soon. Now, I will go through the integration process, showing all the steps required to transfer and receive files. For the example, I'm using Sharekit SDK for Android and Java language, but the steps are similar for Linux and Windows using C and C++. The first step is to create a Sharekit manager and initialize it using the init method. Because it is an asynchronous task, the Sharekit init callback is required to notify the app when the kit is ready. Second step is to define the callback interface used to receive and manage all the updates coming from the SDK, like device discovery and disappearing, and if the status of the peer changes. To register the callback, the method register callback is used. Now, everything is ready to use the start discovery method of the Sharekit manager instance. The SDK will notify the app about the new devices discovered in the callback previously created. To send a file, the core object to create is a ShareBin instance, initialized with the URI of the files to send. Using the method to send of the Sharekit manager instance, we can send the ShareBin object already created. Last step is to stop the discovery using the stop discovery method and release all the resources registering the callback and disposing the Sharekit manager. Now, I will go through another scenario, how to set up a device to receive files. Initialization is the same as the previous example. The only difference is to set another interface, the Wi-Fi P2P Manager X. Next step is to set the device discoverable using start discoverable method. Using a broadcast receiver, the app will be notified when one or more files are sent from a peer device. This is just a broadcast receiver example. Don't forget to register it using the right action. Once the file transfer is completed, it's important to let the device not discoverable anymore using the method stop discoverable and release the resources. Sharekit has a clear development roadmap. Indeed, we are working to add the LAN support and also to remove the dependency of the network adapter. Now it's possible to send multiple files, but in the next release we would like to introduce the possibility to share folders and text. We are also working to improve performances and support more OS and devices. Now it's time to talk about OneHop, starting again from the integration journey. It's similar to Sharekit and all the other kits, starting with the cooperation agreement. The difference here is to choose what kind of integration is required for the device. If it's an app integration, the goal is to have cross-device capabilities between Huawei smartphone and Android devices. Another option is to have a device integration with a fast connection and also file transfer between Huawei smartphone and other devices. Both of them are based on NFC technology. Whatever is the choice, next step is to get access to the SDK, doing the integration, validate it, and then the product is ready for the market. For app integration, it's required an Huawei phone with MUI 10.0 or later. It's also suggested to have a Huawei MatePad with the smart magnetic keyboard. Minimum Android SDK is level 15. For device integration, only Linux operating system is supported at the moment, with kernel 3.10 or later. It's also required to have a device with NFC supporting both reading and writing data, and of course Wi-Fi card with P2P transfer protocol. OneHop Kit depends on UPS applicant 2.6 onward. In order to test, you need a smartphone with MUI 10.1 or later to connect with a OneHop compatible device. The following step want to describe how to integrate OneHop in an Android app. First step is to initialize the SDK and use the package name and the data type to register a service callback. The callback is the entry point to the event. In the OneHop receiver method, the parameter is a JSON string, so it's converted into a JSON object and specific actions are performed based on the current status. Once the task is ended, it's important to release all the resources. There is a lot to say about these two great kits, so please consider this as an introduction and an invite to visit our developer website and discover all the possibility these kits can offer. Thanks for watching and hope you enjoy the rest of the conference.